Welcome back, learners. So now, as we have said, now we're going to our application questions, and they are still based on a parallel circuit. So on the first application question that we have, we are given that what is the relationship between the ammeter reading on A1 and A4, and how do the current strength compare at these 2 points? So we have an electric circuit here that has different ammeter readings. We have A1, A2, A3, and A4. We have our light bulbs and we have our battery connected through the wires and from one terminal to the other terminal. So now we need to look at A1 and A4. This is our A1 and that's our A4. Question is, what is the relationship between the ammeter reading on A1 and A4? So we do know that as the current is moving, or as the energy is supplied by the battery into the current, the electrons or the current will start moving through the wires through A1. Once it gets to this point, it splits into 2 equal parts. Some will have to go through the first bulb, and the other ones will have to go through the second bulb. As before they go through the first and second bulb, they need to pass through A2, pass through A3, go through the bulb as our resistor, then go all the way around. Once they get to this point again, they add up together. So A2 plus A3, they will add up there, and then they will pass through the wires and then pass through A4. Now that then tells us that the current that we started with at A1 is going to be the same current that you're going to have at A4. Why? Because we have now the total current here. Now that total current splits into 2. After splitting into 2, it adds up again here to being now the same current as we had initially, and that same current will pass through A4, which then means that A1 is going to be equals to A4. Why do we say that? Because the total current is the same at A1 and A2. So how do the current strength compare at these 2 points? Current strength is equal at these 2 points. So the current strength is equal at these 2 points. So A1 is equals to A4. Next question. We still have the very same circuit diagram, but then now the question is, what is the relationship between the ammeter reading on A1, A2, and A3? In other words, how do these current strength compare at these points in the circuit? The relationship between A2, A3, and then also that at A1. We know that at A1 we have the total current. Now here, this current is going to split into 2. When it gets to this point, it's split into 2 equal parts. So at A2, we have half the current, and also at A3, we also have half the current, half the total current. Then that is going to pass through the resistors, and then once it gets to this point and pass through A4, we'll still have the total current there. Total current at A4 and total current at A1. So then that means when we add A2 with A3, that is going to be equals to A1, right? So once we add A2 and A3, that is going to be equals to A1, because they are going to add up together here at this point, at this branch there, and then that is going to be the same current as the one that we started with initially, and that is going to be the same current that is going to be passing through A4. So therefore, A2 plus A3 is going to be equals to A1. So how do these current strength compare at this point in the circuit? So we have said that a current, we need to say current at A2 is half of A1. Again, current at A3 is half of A1, which then means now, if these two currents are half of A1, then this now means this equation makes sense that when we add A2 and A3, we are going to get A1. So the current strength at A2 is half that at A1. The current strength again at A3 is half that of A1. But once we add A2 and A3, we are going to get A1. And we also know that the current at A1 is also equal to the current at A4. So because that is going to be the total current. You must also remember that this is only true if these two light bulbs are identical in terms of the resistance. If light bulb number 1 and light bulb number 2 have the same resistance, have identical resistance, therefore this what we have said there is going to be true. Why? Because remember, if light bulb number 1 has a higher resistance than light bulb number 2, then that would mean the current passing through our light bulb number 1 is going to be much lower than the current passing through at light bulb number 2. To make this more practical, earlier on we said, if a light bulb number 1 has a resistance of 6 ohms and light bulb number 2 has a resistance of 3 ohms, light bulb number 1 has a higher resistance as compared to light bulb number 2. However, we do know that the relationship between resistance and current, when resistance increases, current must decrease. So that would then mean that light bulb number 1 will receive a much lower current as compared to light bulb number 2. And that would then mean that this will not be true. This is only true if these two light bulbs are identical and have the same resistance. In this case, we can say they each have the resistance of 3 ohms each or 6 ohms each, and therefore we can conclude by saying that they will each receive the current which is half that of A1. Right. Moving on to the next question now. We now need to look at the 3-circuit diagram and rate the circuits from the brightest bulb or bulbs to the dimmest bulb or bulbs. And then we need to also explain our choices, why we are saying that. Now, these light bulbs are connected. So this one, we can't say that the light bulb A, circuit A, is connected in parallel because there's only just one pathway for the current to flow. However, circuit B is connected in parallel because we have two light bulbs and there's more than one path for the current to flow. If the current gets to this either one of these 2 points, it will split going through there and also going through that branch. So therefore, the current has 2 paths to follow. And then light bulb C, or circuit C, also has 3 paths to follow. There's this branch, that branch, and also that branch. So these two, B and C, are connected in parallel. We can't say A is in parallel because there's only just one path that the current can take there. We also need to know that if we are adding more resistors in parallel, what we are doing is we are decreasing the resistance. So adding resistors in parallel, that decreases the resistance. That decreases the resistance. However, if all these light bulbs are identical, they will each receive the same amount of current. So in circuit B, these 2 resistors will each receive the same amount of current. In circuit C, each of these 3 resistors will each receive the same amount of current. So therefore, that means the brightness in circuit C, the brightness of these light bulbs, all of them is going to be the same. The brightness of these 2 light bulbs is going to be the same. And then this one we can't really say because there's only just one. We can't compare it to any other one on the same circuit. So now to answer the question, we need to now rate the circuit from the brightest bulb to the dimmest bulb. So for a circuit or for a bulb to have to be the brightest, it means that the resistance there must be low. And for it to be the dimmest, the resistance there must be high. So resistance must be high for a circuit or for the bulbs to be dim. And for the bulbs to be brighter, then the resistance needs to be low. So on these three that we have, we do know that as we are adding resistors in parallel, we are decreasing the resistance, which then means that these ones have, or this circuit C has more resistors. That would then mean the resistance is very low, and therefore the current strength is very high. And if the current strength is very high, they are going to be brightest. So C is going to be the first one. So this is going to be C is going to be the brightest. And then obviously B has more resistors than A. So obviously B will have a much lower resistance as compared to A, which would then mean that the second one will then be B. We can just say it's going to be bright, but not brighter than circuit C. And then obviously the last one is going to be A, and that we can say it's going to be dim, or the dimmest. So now it goes like, as you add more resistors in parallel, the resistance is going to decrease in the circuit, and by decreasing the resistance, we are increasing the current strength. And the more the current strength, the brighter the light bulb is going to be. So in this case, circuit C has the lowest resistance as compared to all the other ones in this particular picture. So therefore, the brightness of resistor C is going to be higher as compared to that of B and A. Now, moving on to the next part of questions. So we need to now look at the circuit diagrams and decide which are series and which are parallel, and give a reason for our choices. Which ones of these circuits are series and which ones of these circuits are parallel? So we have circuit A. Remember, for a circuit to be connected in series, that means the components must be connected one after the other, and there's only one pathway for the currents to take. However, if it's in parallel, the components are going to be connected in parallel, meaning that there's going to be more than one pathway for the current to follow. So if the current is moving through the battery, going through the wire, passing through the resistor, passing through another resistor, passing through these are our two light bulbs, passing through bulb number 1, bulb number 2, and passing through a resistor, and then back to the terminal. So in graph, or in circuit A, the current only took one path. There was only just one path for that current to take, and because of that, A is series. A is in series. And then B, again, from the cell, passing through the ammeter, passing through bulb A, passing through bulb B, and then go back to the terminal. And on circuit B, again, there was only one pathway for the current to follow, so therefore B is also in series. Then for C, remember that when these two cells are connected in parallel, connecting the cells in parallel has no overall effect on the current strength. So the current now passing through the wires from the cells, once it gets to this point, some of the current will have to go through bulb A, and the other current has to go through bulb B. And then after having passed through those bulbs, they will add up together at this branch there, and be equals to the same current that we started with initially. So because there's more than one path to follow by the current, this is going to be parallel. And then D, again from the cell, once it gets to this part, it breaks into two equal parts. Assuming that the two light bulbs are identical, then we are going to break into two equal parts. So because there's more than one path to follow by the current, we are saying that this circuit is connected also in parallel. And then E, this current, it is from the cell, from the battery through the wire, bulb A, bulb B. Now, In this case, if the current now, once the current gets to this point, it needs to go through the battery. However, because there's still another resistor there, this current, once it leaves, once now the energy supplied by the battery goes to the current, once the current gets to this point, some of this current has to go through this resistor and some of the current has to go through these two light bulbs. However, they're going to go through. Once they get to this point there at the corner, they will add up together and be equals to the same current that you started with initially. So because of that, because there's more than one path to follow, this is also in parallel. Now the last one, from the battery through the wire, bulb A, bulb B, and then back to the terminal. There was only one path to follow by the current, and we can therefore say this is connected in series. Remember, we're saying it's in series. A, B, and F are in series because there was only one path to follow by the current, and then C, D, and E, it's in parallel because there's more than one path to be followed by the current to move from one terminal to the other terminal, right? Now, before we move on, learners, we're just going to go for a quick ad break, and I will see you just after this.